A dynamical system has states from which the process can still escape. The threshold is the boundary between those states and the absorbing region. Before it, survival is structurally possible. At it, absorption is certain. Crossing the threshold is not a matter of bad luck or poor strategy. It is a structural transition defined by the transition probabilities. The threshold is a property of the system, not of the observer. The first passage time is when the process first reaches the absorbing set. The probability of that happening depends entirely on where the process starts. Large slack means the process is far from the absorbing set. Absorption is less likely. Small slack means the process is close. Absorption becomes more likely. At exactly the threshold, absorption is certain. This gradient from unlikely to certain is the full risk landscape. Every starting position has a well-defined absorption probability. Before the threshold, survival trajectories still exist in the dynamics. A well-chosen strategy can increase the probability of taking one of those trajectories. Larger slack means more room for the process to recover. At the threshold, no survival trajectories exist anymore. Every trajectory from that point leads to absorption. Strategy has no effect. The policy space has collapsed to nothing. This is a discrete qualitative transition, not a gradual loss of control. After the threshold is crossed, 4 quantities are fixed. Absorption probability is 1, it is certain. The effect of any policy is 0. No strategy changes the outcome. The exit probability is 0. The absorbing state has no outward transitions. Future uncertainty is 0. The future is fully determined. None of these values can be changed by any decision, resource, or external action. After the threshold, the dynamics have taken over completely. The model breaks when the threshold is treated as a gradual boundary. It is true that control effectiveness declines continuously as slack shrinks, but crossing the threshold is discrete. The consequence is not smaller control, it is no control. Planning interventions after the threshold is crossed assumes a policy space that no longer exists. Post-threshold strategy is not degraded, it is absent. The model must identify the threshold before it becomes relevant. Once crossed, the structural condition cannot be reversed. This model has 4 structural limits that define where it stops. First, the threshold is exact, not statistical, defined by the transition structure. Second, crossing is irreversible. The post-threshold state is absorbing. Third, strategy only matters before the threshold. At it, the policy space is empty. Fourth, the model assumes scalar state dynamics with Markov transitions and a single threshold. Extensions to vector state spaces or non-Markov dynamics require separate analysis. The point of no return is a structural property, not a risk assessment.